Hi, everyone. Thanks for having us. I'm David, AWS Solutions Architect, specializing in financial services and digital asset trading systems. Today, I'm going to share a little bit on how the digital asset market makers using AWS Bedrock services to do an agentic news analysis platform. So beforehand, I will pass over the time to Wes for a walkthrough what is market making in financial industry.
Thanks, David. I'm Wes. I'm an independent researcher in digital asset market microstructure. Quick disclaimer before we dive in. So the views I expressed today are on my own and don't necessarily reflect AWS official position or any organization I may be affiliated with. This is for informational purpose and not any financial or professional advice. So that's the disclaimer. So let's start with a big picture, the trading ecosystem. So in the trading ecosystem, there are some buyers, some sellers in the financial market. So the buyers and sellers will place their orders into an exchange indicating they want to buy or sell something. But there may not be always having enough liquidity in the market. That's where market makers come into the picture. So the responsibility of a market maker is to always quoting a buy or sell orders, making sure there is always enough liquidity in the market. So there are always there's always a counterparty in the market to help you trade against you. So whenever you walk into the market, there's always you can always buy or sell to some people. So this is abstraction of an order book. So in the left-hand side, it indicates the bid orders, and the right-hand side is the ask order. So the y-axis is the cumulative size in that price level, and closer to the right-hand side is higher the price. So you can imagine in a daily work of a market maker, they place multiple bid orders on one side and also multiple ask order on the other side. So imagine if there is a news or an announcement coming up, the market may move significantly, and then all the ask orders may be taken by some other market participants. This could be a risk to a market maker because as a market maker, we need to manage our inventory well to make sure we have enough inventory to place ask orders. If the market goes up suddenly and didn't fall back, so only the ask orders are executed without the bid, then the market maker may need to refill the inventory by buying the inventory back from the market at a higher price, meaning the market maker may need to sell at a low price and buy at a high price, which may incur a loss in the market maker portfolio. In an ideal situation for market maker, the market should swing only a little bit within a controlled volatility. So in the ideal case, the bid orders and the ask orders are executed in a very short time. So even though the profit of each trade may be small, the turnover rate could be very high if the market keeps swinging. So one may ask, can the market maker increase the spread so large that every time the trades could get you a better profit? This is a trade-off between turnover and P&L. Usually, the market maker chooses to execute trades in a more high-frequency way, but each trade having a small profit. Let's say if you increase the spread to so high, there could be chances that your orders cannot be executed even once in a day. So to maximize the profit, market maker tends to execute it in a high-frequency manner. And given that volatility is a very important component in the price formula, so if as a market maker, I know the market is going to be very volatile, then I can increase the spread before the event happens. So there are a lot of factors affecting volatility in the markets. For example, FOMC is going to discuss the Fed fund rate next week. So as a market maker, we would like to listen to the news, try to analyze how the news is going to impact the market as soon as possible. So if the Fed fund rate cut is more than expected, then you know the market is going to go up. In that case, the market maker need to modify the orders as soon as possible. Otherwise, there may be some other market participants or competitors taking all the ask order and resulting a loss in the market maker. All the analysis have to be done as fast as possible. So we are talking about maybe in just a few seconds, we have to finish all the analysis, determining how the market is going to be impacted and action in the market immediately. According to Chris from IG Group, the immediate effect of Trump's market moving tweets typically lasts around 30 minutes. So I'm sure you know about Trump makes a lot of tweets related to tariff few months before. And actually not only Trump's, Elon Musk is another very good example. So a few years ago, there was a period of time Elon Musk keep tweeting about cryptocurrency. So sometimes he write a tweet about, oh, I like some dogs. Then the Dogecoin price may go up immediately. So compared to traditional market news like FOMC meeting result, Elon Musk's tweet is much more difficult to be interpreted. So for the FOMC meeting, we know that when it is going to help to release the result. So we know exactly when the result is released. We know the result is just a number in the Fed fund rate. So we know how to do the comparison. Or if the number is higher or lower than the market expectation, then the market direction will be up or down. But in digital asset world, the case may be a little bit different. So using Elon Musk as an example, so the tweets could be just some words. So today he may say, I like a particular cryptocurrency so much. And on the other day, he may express his opinion on another cryptocurrency that, oh, maybe this is not a really good one. Interpreting the key opinion leaders or influencers' tweets is one of the challenging tasks for market maker because this is something this is not something foreseeable, and this is not something numeric. You need to interpret the tweets intelligently. So sometimes even if you try to do manual judgment on the tweets, even human judgment may take some time to process it. And if you're putting it into a program or algo trading world, it is not acceptable to wait for human intervention or to judge if the tweet or the news is going to impact the market up or down. That's why we need some LLM to help us to judge if a news is going to have impact on the market, and to judge if the news is going to have a positive impact or a negative impact. So I'm going to pass the time to David on.
Thank you, West. So before we get into the solutions, let's understand what we became before. So in the industry, the first approach to tackling this news sentiment analysis, we start beginning with the dictionary approach, with dictionary matchings. Usually we'll have some industry sentiments lexicons like bearish, bullish, crash, wordings like this. And we put it into a simple pattern matching algorithm. However, you can imagine the problems here is, with the limited vocabulary, you can't handle context very well. So for example, if there's a news title, massive short liquidation event, you probably get a negative sentiment. However, it should be a positive one. So the industry start moving from dictionary matchings to statistical matching machine learning. With labeled data supervised learning, we use models like naive Bayes or Finbird on financial corpora. We will get better generalizations in this case and understand the news context. However, this requires massive label data training, which means it costs you a lot in terms of spending and also the time to market for these solutions. So nowadays, we all have the large language models, where we are using the transformer-based multimodal reasoning. Now you can, with this LLM, with this kind of like LLM, like Claude, DeepSeek, you can do context awareness with minimal or even no fine-tuning needed. You can reason it on specific news title, even say like with domain-specific events, maybe like if a protocol exploit being exposed, you can ask the LLM with reasoning model that whether this has cross-chain impact. So this is the foundation of the agentic approach. However, with this LLM, the inference performance matters. Remember what Wes just mentioned. This is a new sentiment analysis on a dynamic moving market with very short time window we need to react. So we need to do the inference optimization. Here's the journey. So in earlier this year, February 2025, we start this deployment using a SageMaker Jumpstart on P5EN instances, where we resulted with 80 tokens, output tokens per second. Not good enough. Later on, in April 2025, we replaced it with VLLM. For this, we can enable DeepSeek multi-token predictions, mixed precision linear attentions, also combined with distributed expert parallelism. Then we have the result boosted to 140 output tokens per second. Still not good enough. In August, we replaced it VLLM with SGLang. And this, with the help of speculative decoding, finally we achieved 180 output tokens per second. So why does this matter? Imagine when you have 10,000s of events per minute, every millisecond of inference latency will compound. Going from 80 to 180, which means that we can double our news ingestion processing in the same time window. These optimizations enable the end-to-end latency under 10 seconds. That avoids the average selections avoidance possible. So let's talk about the implementation. Here is our day one architecture. So from the bottom layer, you see we keep ingesting news streaming in with news streaming API, going directly into our S3 bucket and trigger the event bridge. We trigger the Lambda for doing classifications on based on asset, urgency, and sentiment. With this Lambda function, it will trigger the DeepSeek model for tagging all these metadata into the database, including Aurora Postgres and also the OpenSearch. We also utilize the Q CLI for the terminal so that even trader, the business analyst, can interact with these news sources to ask the LLM, ask the clock in the Bedrock, say to figure out the latest news about, let's say, Trump announcements or whatever. Let's say the last 10 hours what the Elon Musk is speaking on or publishing in the X feed. But here's the hidden challenge. In crypto, in digital asset, the same news gets reported 50 times. For example, like Ethereum upgrade delayed appears on Twitter, Reddit, Discord, the Telegrams, all over it, and all within minutes. So if you process every duplicate through the expensive LLM, you will burning money, you will burn and killing the latency. So we have another deduplication pipeline to handle this problem. First, step one, we want to calculate the embeddings in the Lambda, calling our embedding models BGEM3. So, and then we do the similarity check. If it is greater than 0.75, which means it is a duplicate, we insert that into the duplicated collections in the OpenSearch. So if we stop here, we don't waste the LLM tokens. What if the similarity under 0.5? It means this is likely a unique one. And then we will check these against with the unique collections to make sure that this is against the historical news stored in our OpenSearch. The third step will be going to the analysis where if this is truly unique, then the second lambda will does the near real-time predictions, and then we're trying to do the spread widening recommendation, also asset impact assessment, and price movement probability. The last step will generate the prediction report and send it to the trader desk Slack channel, and let human decide whether to act. But here's the subtlety. Generic embedding models aren't great to do these crypto-specific duplicates. That's why fine-tuning the embeddings matters so much. Here is the scatter plot shows a out-of-the-box BGEM3 on thousands of query documents pairs from crypto news. The green dots, the upper part green dots, is the news articles that are duplicates. You want high similarity scores, ideally greater than 0.75. The red dots reveals the negative pairs, the news articles that are not duplicates, and you want low scores, ideally below 0.5. So the problem you see, in the muddy middle between 0.5 and 0.75, the orange threshold is a massive overlap. So we need to do a better fine-tuning on this one to have a better understanding. So this is after the fine-tuned BGEM3 on thousands of labeled crypto news pairs, you see now the green dots and then the red dots is separated much more. The muddy middle is already gone. There's a clean separation between 0.3 to 0.6. So this is beautiful. We now fine-tuned the tiny embedding models with just 560 million parameters. And this is, for the LLM, you don't need to do any fine-tuning. Just prompt engineering. This is the power of agentic architectures. So here we have a very quick demo. And you see, this is at the right-hand side, this is where the trader decks are getting the news channels. And then the left-hand side, we are streaming through the news and then let our pipeline to analysis to analyze whether this is an important, impactful news. The first one you see, this is SEC filings. It is an analyzing for that. It doesn't send to the trader desk because this is from the reasoning model, it is not indications of contains any market moving informations. It is just not a major regulatory filing. And then further on, it will keep ingesting the news, keeps analyzing. Still, we will classify this is just the routine news. And when there's a news pump in, Trump is kind of like sending us China becoming a hostile, very hostile, this kind of like feeding into our Telegram feed. You see our pipeline identify this is a very impactful news and pump it to the trade, let the trader to decide whether to increase the spread to protect the portfolio. So this is our demo today. And the key takeaways we would like to share is use the agentic architectures over fine-tuning. It will help you use the general reasoning models like Claude for the hierarchical task decompositions. And then you can, for these specialized embedding layer, will give you more cost-effective and better, faster time to market results. And you can do the bias elimination through the architectures. You teach the system how to reason about novel events. Human in the loop is still non-negotiable, but now you can use the trader feedback loop to change the system over time, which result that we have the 24/7 real-time coverage with human oversight. So this is our sharing today. Hope you find it useful. Thank you.